Okay, we are going to solve this problem, the problem 7.1 from the part 1 of metric geometry. Okay, so we have the statement of the problem where it says that given a plane formed by or defined by these three lines A, B, C, or these 3 points A, B, and C, we need to model a line R which is located in the right plane, which is this one, the right plane, although this plot doesn't show that well that it's on the right plane. And the line R forms an angle of 30 degrees with plane ABC, with that plane. And then when we have defined the line R, we need to compute or to calculate the angle between the line R and the top plane, which is this one, the horizontal one. Yeah. So we can download here the statement that I have it here already, and then as usual what we are going to do, we are going to define a 3D sketch where we will find the solution. But before that, I'm going to define the plane formed by these 3 lines, which is not given here. So I go here to features, reference geometry, plane. It is a bit slow, but yeah, I define a plane defined by those 2 lines. If I set the third one, will be like over definition. So I say okay, so I have plane A, plane 1, and you can change the name if you want and say plane ABC. Okay, so then I define a 3D sketch and I call it here the solution. Okay. And then it says here in the statement that the line R is located on the right plane, which is this one, the right plane, or vista lateral. So pay attention that if you double click on that plane, we edit it, and now everything that I will model, it will be on that plane. So for example, if I plot here a line, that line will be always on that plane. And then I click outside twice, and then I'm outside. Yeah, so you see my line is here on the right plane of vista lateral. And then it says that this line form an angle of 30 degrees with that one. Yeah. So then we need to define the angle, and you remember the angle is made in the projection of that line with that plane. So I could put this point on the plane and define the projections. For example, this, when this line is coincident with that one, I could find the projection, but you don't need to do that anyway. So I'm gonna do it with this. So I'm gonna make one line which will be perpendicular to the plane, and another line will be parallel to the plane. So that line will be the projection. Okay, so you see it is not on the front plane. It can be a mistake if you define those lines in the front plane. So then I said this line is parallel to that plane, yes, and that line is perpendicular to that plane. It's a bit slow today. Okay, and it goes to here, and it says that that angle is 30 degrees. Yeah. So I put here my 30 degrees. I don't know why it's very slow, my computer today. Anyway, 30 degrees. However, you see that we are measuring the angle from this plane to the line on that direction, but it will be another solution. We know already that it will be another solution if we measure the angle from here to there. So for example, I could find another solution . Okay, now it's slow today, yeah. Okay, I plot two 2 points. So I could find another solution where my angle will go from here to there, just to know that any time that we measure an angle, we have 2 potential solutions. Yeah. So I do the same. This perpendicular to the plane, this one parallel to the plane. Sometimes you make the mistake that you define a line parallel and this one perpendicular to the line, and that's a mistake. It has to be perpendicular and parallel always to the plane. And also pay attention that we always measure the angle with the parallel, which is the projection line, 30 degrees. So you see these 2 lines, they are both on la vista lateral, on the right plane, and they both have an angle of 30 degrees. Yeah. So these are my 2 solutions. Yeah. And there it says that once that I have that solution, calculate the angle between the line R and the top plane. Yes. The top plane is the plane horizontal, and then I have to do the same. I have to do a perpendicular and parallel to the top plane and define my angle. Parallel, perpendicular, and then my angle will be this one. No, too slow. Okay, try again. 8.20. So this is the exercise 7.1. So 8.20 is one of the solutions, and the second solution should be this one. So this will be the perpendicular to the top plane, this will be the parallel, and then I click Control, top plane, perpendicular, and this one will be horizontal, parallel to the top plane. And then my angle will be 65.13. Doesn't let me to choose the angle because it's already defined, and let me check if it's the solution. 7.156.13. Yeah, so I think that's fine. So yeah, that's the solution to the 7.1 problem. Okay.